Okay, so hello everyone. Today we'll be discussing this research paper, Reflexion, language agent with verbal reinforcement learning. So, as the name suggesting reflection, there could be some kind of reflection, self-reflection, like we reflect ourselves when we make mistakes. So, it is a kind of similar thing. When we generate some output in using LLMs, so there is some kind of you can say critic or reflecting system. So let's say okay, you did this wrong, you did this right, you can improve it like this. Let's say you ask it to write a poem on rose, so it give you a poem. You say okay, make it more funnier, okay, make it uh, like more friendly, or make it more serious, or make it more like more energetic, like these this kind of things. Okay, we'll go more in depth as we go through the uh, research paper. Okay, so I will also sharing this annotated PDF, so if you want to just have a go, you can check it out in the description. Okay, so just let me start. Okay, so here it is saying that is using reinforcement learning. It takes basically a lot of training sample, and also fine tuning it also is expensive. Okay, so here you have developed reflection system, a novel method. Here we not go for updating weights, but instead improve by using linguistic feedback. Linguistic is just using words. Like, well, in reinforcement learning, we what is reinforcement learning? Simply, we take action and then we learn. We learn by trials and errors. And how do we know that there is this action is right or wrong? There is a reward system. We know through rewards. Rewards basically a bunch of numbers. Like you say, Acha, there's from this action the reward is 5. From this action reward is 10. Okay, reward is higher, so we go for that method. But here there is nothing such as numbers. Like we go for words, like sentences. Like here we say, okay, Ayush, you are sitting like this. This is wrong. You sit like this. Okay, hold your spec like this. Like you are giving some more meaningful reflection or meaningful remarks to how to improve your output. Create this is written reflection agent verbally reflect on tasks feedback signal that can maintain the reflect system in episodic memory buffer to introduce. Okay, there's a memory. There's also memory, like we store our previous few reflections. Great. And there's also this. This is just a benchmark, human evolved coding benchmark. Okay, I will try to open it. And this is a metric pass at the rate 1. Basically when our model generates nahi hai. When our model generates the code, or when the code generated by model, it passes out all the test cases in the first attempt. So it is called pass at rate 1. Like if it passes, then it is yes. If it does not pass, it is no. It's simply a metric to judge whether our code it's actually passing out test case or not. Okay, here well power register used to test how well our language in Python के form में 50% problems. Great, let me close it. Okay, that is for few terms. Cycan tool form of Hugging GPT. Okay, just go through it one time. Stay calm. Okay, so here we combine LLMs with robotic control. Great, and close on that. And tool former, a model teaches itself how to use external tools. Okay, you can look at it later. And in a Hugging GPT, there is one main LLM, and it decides which agent or which LLM to use. It is a very high level kind of understanding. We can go much in depth in all these things. Okay. There is a concept of in context learning. So here basically we know the LLMs are like very expensive to train, like they contain millions of parameters. So instead of training in them entirely from scratch, we give them some few examples in the prompt, and this comes is called in context learning. And then after passing some examples, we then simply ask our questions. Great. So here it is. Reflection will convert binary or scalar feedback. So here what I was saying, if we get any like numerical feedback from the moment, so it will change it into textual form. Great. And okay, see this added additional context for LM, and in the next query which we ask, it is already added in that. So kind of we have memory part. See if it's written or not. Okay, we'll find it later. And there's a term, this self-reflective feedback acts as semantic gradient signal. Gradient we some like to improve or something. Gradient, like in machine learning models we see gradient to improve the weights. So it's semantic kind of words thing. And see, like gradient tells how to improve the weights. It is similarly these feedbacks help us to like improve our LLMs, but they are kind of words, so we use semantic word. Great. This part is very important. Generating useful feedback is challenging because it required a good understanding of where the model make mistake. How will you tell like you did something wrong, when you have to know, like if you're an expert then only you can tell, okay, you did wrong here, you did wrong here, how you can improve. And second, an ability to generate a summary containing actionable insight for the improvement. Okay, so you know, acha, he did wrong here, like he did wrong in the syntax, and I know how to improve it, and how and getting a summary, how can I explain him. You can think in that way. So the critic assignment problem, this is a very important term. So create assignment problem. So let's say we had a model, we got some output, and how do we know like which action the model took is was right or wrong? Like in the entire model, there are various steps, there are various parameters. It takes several actions to get a final result or prediction whatever we are doing. So how do we know that okay, this action or this part was right or this part was wrong? Like how do we assign credit or reward something? So when an AI gets a result, good or bad, how to figure out which part of his behavioral decision has actually caused that result, and that is how we will assign credit to each action performed. So this leads to credit assignment problem. It is very common, like important term. I think it will come. I will face this term again in future. And a second, ability to generate a great. Okay, so here is it's comparing reflection with traditional RL. So its advantages are it does not require fine tuning in the LM. Okay, since we are using in context learning, we are simply giving some examples beforehand. So it is very important. It allows for more nuanced form of feedback, like targeting exchange action rather than compare a scalar or vector rewards. They are challenging to understand. When instead of using some bunch of numbers, sorry, uh, using rewards like numerical 5, 10, instead we say, okay, you are doing this wrong. Write the sentence shorter, longer, make it more friendly, make it more serious. Like you are giving a better remarks to so that the language can easily understand. Model can, LM can easily understand. Same here, a lot more static. Here also the memory part. Okay, we'll discuss it later. But here was it written that it also have a disadvantage. Like in reinforcement learning, we have a proof of everything. We have mathematical proof. But in LLMs, like this is more of a conceptual thing. We don't have a mathematical formulation to prove this. Like it doesn't surely work. Great, great, great. There was I think self-refined technique of rework, which was developed earlier. So here basically we are keeping a constraint, like how this model can be written in a more positive way. So you're getting it, like you, yeah, our LM is getting and giving some output, but we are our reflection is in a certain direction only. So kind of we are getting some constraint. Okay, okay, great, great, great. The past one we discussed, metric used to measure performance of code generating AI models. So if the model passed in the first attempt, yes, then no. Great, huh? So basically this part is important. In Reflexion there are three major part. Actor, like a just kind of generator or something gives an output, generate text or action. Great. Second is evaluator, like we are evaluating how our text or actions are, like you're giving it good, better, best, like some kind of evaluator. There won't be something like, it will like score 1 2 3 5 5 6 1 out of 10, whatever we define. And there is self-reflection model. So after on the evaluator they say, okay, we got this, how can we improve? They're saying verbal reinforcement cues to assist actor in self-improvement. That's what I want. Verbal reinforcement cues in assisting actor in self-improvement. Great, there's a diagram. Fill the code a bit. Okay, I will speed up a bit. Actor specifically prompted to generate necessary text and action condition to speed observation. Great. There is also concept of memory. Okay, there are two types of memory: short term and long term. Long term come from the reflection part, like we keep the previous, let's say some reflection 2 3 5. In the paper we have kept 1 to 3 reflections. It will be shown later on, 1 to 3 reflections. Great. And there is other short term memory. So basically it's kind of observation we got from that moment. Okay, evaluator. Okay, evaluating parts, reflection part. And there is a memory though there is two type of memory, short term and long term. We are using them both. Great. These two memories work together to take care, make things better. Reflection. Okay, here is reflection process. They is saying the memory component of reflection is crucial. We obviously, and after each trial, the STR as SRT is appended to MEM. SRT by our reflection part, verbal reflection, and in practice we kept MEM memory by maximum number of stored experiences, omega, which is set to 1 to 3. Great. There is experiments. Okay, you can go through all these. I won't go in much more detail. Let's see what was written. Okay, grammatical errors. Yes, so and when they were using combination with reflection, things got better. Great. Okay, I have highlighted almost. So there is 6 to sort on. Let's say there's 6 sort mounting. So we giving 6 examples beforehand. 2 sort mounting, 2 examples. And holistic. Okay, exact match search. There was a concept. Basically, exact match we are matching like exactly 2 words. Let's say here then mass won't be equal to this. There's one capital, one small. So basically, he was saying that here they are using exact match search, and also if you want to make things better, we can go for F1 score or semantic similarity. Okay, great. Okay, you can look at well, let's go for limitations. Okay, in this study, we limit our long-term memory to a slanting window. No, we was using only like previous 1 to 3 experiences only, but we can use like vector database like FAISS or SQL database. Great. And there were some issues we faced while testing the like our code generation part. Great. And there's also one part in RL, like the things are like black box. Like when we get a numerical feedback from the moment, like all the rewards are numbers, so it is difficult to understand like how exactly the model is improving. We know the what and things are improving, but like what kind of remark or rewards it is, what kind of feedback it is getting from the environment. Great. So in visual learning, it is difficult to understand exactly what feedback it is getting from the environment because all are the numbers only. But here we are using verbal feedback, so things are easier to understand, more interpretable and diagnosable. Great. This is simple. This was a thing. I haven't gone much into that and in the experiment parts. You can read it later. Okay, then bye bye till then. We set it.